Let's take a look at our homework assignment using the quadratic formula. Let's identify our values of A, B, C. Put those into the quadratic formula. Okay, now right off the bat, see the B is negative, so that makes this 4 plus or minus square root of B squared minus 4 times A times C all over 2 times A. And then what I'm going to do is simplify that. First of all, the denominator is 2 times 1 is 2. The discriminant is this information. So you can get out your calculator if you want to. I think we could probably do that one mentally. So negative 4 squared would be 16 minus, when you multiply that stuff together, it's 12. 16 minus 12 is 4. So I think we can all agree that this will be 2. So this turns into 4 plus and minus 2 divided by 2, which really leads you to 2 different solutions. Okay, so one solution would be 4 plus 2 divided by 2, which is 6 divided by 2, which is 3. So there's one answer. The other solution coming off this would be 4 minus 2 divided by 2, which is 2 over 2, which is 1. There are the 2 solutions for that problem. Let's take it down to number 9. Once again, let's correctly identify. There's A, there's B, and wait a minute, we're not ready for that yet, are we? I didn't notice that. We've got to move that over there. So hold on for a second. Let's move this over here. Let's rewrite this. That'll be a plus 49 when it moves the other side. Now I can correctly identify. Here's A, B, and C. I'm ready to get into my quadratic formula. The opposite of B, so that'd be 14 plus minus square root. Here comes a discriminant. B squared, now if it's negative, remember to do that. Put it in parentheses, minus 4 times A times C. So we got some larger numbers here. Might need the calculator. Over 2 times A. I'm going to go ahead and simplify that. So it'd be 14 plus and minus. We'll calculate the discriminant here in just a moment. The denominator is 2 times 1. So I think I'll go to my calculator. I know negative 14 squared is 196, but the other stuff, I think I can figure it out, but probably be better off being careful and using the calculator. So there's the first part. Let's see what we get here. All right, we get 0. Interesting. So the implication here is if that discriminant is 0, the square root of 0 is 0. This is going to give us only one solution. So what we're left with here is x equals 14 divided by 2, which is 7. This is one of those quadratic functions that would only touch the x-axis at one place. It is tangent to the x-axis. On to the next problem. 14. Now, once again, we got to rearrange this in the standard form. That term's going to need to go right there after the 5x squared. So it'll be positive 4x once we do so. Let's identify A, B, and C. Here's A, B, and C. Let's use our quadratic formula now. Okay, the opposite of B, so that'll be negative 4 plus and minus square root. Here comes the discriminant. B squared minus 4 times A times C all over 2 times A. Let's go ahead and simplify that a little bit more. So we've got negative 4 plus and minus. We will calculate the discriminant in just a moment. In the denominator, when you multiply, you get negative 10. So let's look at this discriminant now. Once again, you can turn to your calculator if you want to. That's going to be 16 minus 120. That would be negative 104. Calculate that. Make sure we got that correct. 16 minus 120. Yeah, that'd be negative 104. So we got a little bit of work to do on that negative 104. I know it's an imaginary number. So I know we're going to try and simplify this radical. So it's negative 104. All right, I got to do a little bit of work with my calculator because off the top of my head, nothing pops in there and says, hey, that's divisible by a perfect square, but it might be. So what I normally do is I take 104 and I cut it in half. So that'd be like 52. And take the first perfect square that's close to 52. How about 49? Is this divisible by 49? No. That was 7 squared, right? How about 6 squared? That's 36. No. 5 squared is not going to work because this number doesn't end in a 5 or a 0. 4 squared is 16. Maybe this is divisible by 16. No. Is it divisible by 9? No. Is it divisible by 4? It is. We found it. So it's going to be radical 4 times radical 26. Wow, that took a long time, but we got it. So I know there's an I out there. Okay, so this is what we're dealing with. Now when I look at this, that's going to be a 2. So let's rewrite this. Negative 4 plus or minus 2I radical 26 divided by negative 10. Okay, we've been working on this. Now, can you reduce that more? Yes is the answer, because if I focus on this number, and this number, can you find a number that's a common factor? And I would say it would be 2. And in fact, to be technically correct, since we have a negative in the numerator and denominator, let's divide all of those by negative 2. Everybody got that? Divide all of them by negative 2. And here's the answers. So 2 plus and minus. So this 2 here will cancel out. I read 26. Divide the bottom number by negative 2 would be 5. And there we go. There's our 2 answers. That's kind of a tough one to simplify, but that's the way you think through it. Okay, let's go to 15. This one needs to be rearranged as well. So we'll go right here. So this will be negative 4x squared plus 3x plus 5 equals 0. Here is A, here is B, and here's C. We are ready to use our quadratic formula. Opposite of B plus or minus B squared minus 4 times A times C all over 2 times A. Try to simplify that a little bit more. Negative 3 plus or minus the discriminant. We'll calculate that in a moment. The denominator is negative 8. Okay, let's take a moment to look at this discriminant. And let's calculate. Okay, so 3 squared is 9. Negative 4 times negative 4 is 16 times 5 is 80. So this is going to be 9 plus 80. That's 89. Can that radical be reduced? Gotta go back to the same thing we were doing before. Okay, so you got the number 89. We're gonna start dividing that by perfect squares. Okay, let's just say it's 90. Half of 90 is 45, right? So 36 is the first perfect square that's under 45. Is this divisible by 36? No. There's no way it's divisible by 25. Could it be divisible by 16? Perhaps. No. I know it's not divisible by 9. How about by 4? Oops, I don't think so. No, this is reduced as far as it can be, which raises an interesting question. These two negatives here, we're going to allow those to cancel out. So technically our answer will be this. And I don't see anything else we can do in that problem. On to the next question. 17. Now, you may have done this differently, but I think the easiest path to get this in standard form is to move the z squared to the right, which makes it a positive value. Actually, let's identify A, B, and C. A is 1, B is that negative 12, C is 6. Let's write our quadratic formula now. So opposite of that number will be 12. And here comes B squared minus 4 times A times C all over 2 times 1, which is A. Let's try to simplify this as much as we can. We'll calculate the discriminant in just a moment. All right, let's take a moment to look at this discriminant, see what it tells us. Okay, well, negative 12 squared would be 144. 4 times 6 is 24. So it's 144 minus 24. So that's 120, right? So I'm going to write 120 right here. And I'm wondering if we can reduce that. I bet we can. So let's move down here and let's see if we can write that radical as a product of two radicals where one is a perfect square. So if nothing pops in your mind or off the top of your head, let's take 120, cut it in half. That's 60, right? So what's the closest perfect square to 60 under it? 8 squared, 64. Let's go 7 squared, 49. I don't think 49 is going to work, but we try it anyway. How about 36? Does that work? No. Try 25. That's not going to work. Think about money. How about 16? No. How about 9? How about 4? That's going to work. 30. Okay. So 30 and 4 multiplied together work. So radical 4, radical 30. And now we can see that this is a 2. So this will be 12 plus or minus 2 rad 30 over 2. Do you think you can simplify more? Let's look at these rational numbers. Yeah, you can. Divide them all by 2. 6 plus or minus 1 rad 30, or just 30 divided by 1. So that's it. Don't need to put the division by 1, do we? Okay, so I'm sure that's one of the more difficult parts of these questions is reducing these radicals and working with them. Last question. All right, so what do we want to do here? I'm thinking the same thing we talked about in the last question. I don't know about you, but I'm just going to move that over here. Now I've got it in standard form. Now I can see that I've got A, B is that negative 7, C is 6. I'm ready. I'm going to write this quadratic formula. Take the opposite of that. So that's B plus or minus. Here's the discriminant coming up. B squared minus 4 times A times C all over 2 times A. Let's reduce this a little bit. 7 plus and minus. Discriminant there in a moment. 2 times 4 is 8. Okay, let's analyze this discriminant, everyone. Turn to the calculator for this. I think we could probably do that mentally, but what the heck? Let's just do this. Oop. Okay, I think we got a little bit of an issue. All right, here we go. Clear that out. So we've got -7 squared, which would be a 49, right? -4 times 4, which would be -16, times 6. It's like 98. Okay, so we've got a negative number here. -47. 47 might be a prime number. You can work with that. I don't think it's going to be anything that we can reduce, but it is going to be an imaginary or complex solution because of that negative. So let's rewrite this. That negative right there is going to be I, so it's going to be 7 plus or minus I rad 47. You can work with that. It's not going to reduce over 8. There's your answers. All right.